In this video, you will learn about the homologous series of the alkanes and alkenes and their structure. Before we look at the structure of these molecules, you may wish to recap your understanding of bonding by watching our covalent bonding video. Alkanes are saturated hydrocarbons, meaning they contain only single covalent bonds between carbon atoms. A single covalent bond is a shared pair of electrons. Let us take our first alkane in the series, methane, CH4. Carbon has 6 electrons in total, 4 of these being in the outer shell. Carbon, therefore, always needs 4 more covalent bonds to be stable. In methane, the 4 hydrogen atoms have only 1 electron and so covalently bond to the carbon atom, each sharing a pair of electrons. Methane is known as natural gas and is often used as a fuel in homes for heating and cooking. It is also the gas released by cows by belching and flatulence, as it is produced by the fermentation of food by bacteria in their stomachs. The next molecule in the homologous series of alkanes is ethane with 2 carbon atoms. As you can see, a single covalent bond is formed between the 2 carbon atoms, with 6 more hydrogen atoms covalently bonded to complete the molecule. Now we understand the way these molecules are bonded, we can show the next molecule in displayed formula, representing the covalent bonds simply with lines. Here is propane, followed by butane. This alkane series continues and follows the general formula CnH2n plus 2. A general formula allows us to describe a series of molecules that differ from each other by a constant unit. Let us look again at ethane. Using the formula CnH2n plus 2, where N represents 2 for the 2 carbon atoms in ethane, we can see that the number of hydrogens will be 2 multiplied by 2 equals 4, plus 2 equals 6. So 6 hydrogens, C2H6. Using this, we can find the molecular formula of other alkanes. For example, decane, an alkane with 10 carbons. Pause the video now and use the general formula to work out the structure of decane. You should have got the answer C10H22, where N equals 10 for the 10 carbons. Therefore, 10 multiplied by 2 equals 20, plus 2 equals 22. 22 hydrogens. Let us look now at the homologous series of the alkenes. These are unsaturated and so contain a double covalent bond between 2 carbon atoms. Here is ethene. Since there is a double bond, there are now 2 shared pair of electrons between the 2 carbon atoms. Each carbon atom now has only 2 electrons which covalently bond with a total of 4 hydrogen atoms, 2 on each carbon, to complete the ethene molecule. You are only likely to come across alkene molecules with just 1 double bond, although there can be more within a molecule. The next molecule in the series is propene. As before, there is a double covalent bond between 2 of the carbon atoms, but the other is just a single bond. We now need to fill the molecule with hydrogen atoms to ensure that each carbon has a total of 4 bonds. 2 hydrogen atoms are required at this end of the molecule. This middle carbon already has 3 bonds and so requires just 1 hydrogen, and at this end carbon has only 1 bond and therefore needs 3 more hydrogens. Since we now understand the covalent bonding in these molecules, let us replace the dot-cross diagram with the structural formula. Here is the structural formula of propane. Pause the video now and try and complete this structural formula of butene. Here is the completed structure. Did you get it right? Here are the structural formulas of the first 4 alkenes. Pause the video again and try and complete the general formula. What is the relationship between the number of carbons and the number of hydrogens? Hopefully you got the structure CnH2n. Quite simply, there is double the number of hydrogens than the number of carbons. So, as an example for decane, the molecular formula would be C10H20. Now, at the end of this tutorial, you should have a better understanding of the bonding in the alkanes and alkenes, and how each homologous series follows the pattern given by its general formula.